Hey, how are you doing, guys? I'm Dahan. For today's lesson, I'm gonna talk about multi-label classification and how to make our model recognize unknown images. So here's our outlines for today's lesson. First of all, we're going to set up our environment, and for our multi-label classification task, we are going to use Planet dataset. Then I'm gonna show you three different ways to customize the DataBlock API. The first method by using DataBlock, the second one by using Lambdas, and the last one by using getItems function. Then we are going to build our CNN learner. Then we are going to define our custom loss function, finding our optimal learning rate, and the last part is going to be about recognizing unknown images and the difference between multi-label and single-label classification. Okay, here is my note, and let's get started with the first task, which is multi-label classification. So first of all, we need to set up our environment. So we need to install the libraries that we will use. So as you can see here we install fastai library, and I have explained to you how to install it in the first video. Here we install it by using pip install. Now we need to grab what we need. So for our multi-label classification task, we need to grab two things. We need to grab first we need to grab our vision library, then we need to grab our data. So as you can see in this cell here we grab our vision library. So from fastai.vision.all import asterisk, which is import all. So this line of code here is going to import the vision library for us. And for our data, we are going to use Planet dataset, which is collection of satellite images with multiple labels describing the scene. So to grab it, we are going to use enter data method, pass it the URL of the data. So this method is going to extract and download our data from this URL here to our local directory. And for pd.readCSV here is going to create a data frame with image file names in the first column, and the second column is going to be our labels. So let's go with my notes. So here's what I have covered so far. And for our data frame is going to be like this. So as you can see in the first column, stores our file names, and this column called image name. And for the second column, call tags and store our labels. And this our data frame. So image. So in the first column, image name store our image file names, and tags stores our labels. Okay. So there is three different ways to customize our DataBlock API we are going to cover. So the first method by using DataBlock, the second one by using Lambdas, and the third one by using getItems function. So let's go with the first method by using the DataBlock. Okay, so to build our data block, we need to specify our blocks, our getX, our splitter, our getY, and our batch transforms. So for our blocks, our data block is consisting of two blocks. The first block is image block, and the second block is a multi-category block. And for getX parameter here, it specifies how to read the images. So in our case, we are going to use a column reader to read our images from a specific folder. So this folder is Planet source. Go to train folder and grab our images with .jpg extension. And for our splitter, we are going to use random splitter. So this is going to split our data randomly into 80% for training and 20% for testing. And for our getWise parameter here, this specifies how to read our labels. So in this case, we are going to use a column reader to read our labels from the second column from our CSV file. And for batch transforms parameter here is going to specify the transformations that apply to a batch of images during the training. So here we pass it the batch transforms variable here. So this variable is going to apply set of data augmentations to each batch of images during the training. This transformation including vertical flipping, changing the lighting, zooming, and wrapping. And here we define our data loader by passing at our data frame. Then we show a batch of 9 images from our data loaders. And let's go with the second method. So in this method, we will use Lambda function to grab our image names, which will get rid of column leader. So as you can see here, we define our blocks. So as I told you in the previous method, our data block is consisting of 2 blocks, image block and multi-category block. And for getX here we are going to use Lambda function to grab the path of our images instead of using column leader. So here's the path of our images. From planet folder, go to train and grab all images with .jpg extension. And x of 0 here is referred to the first column from our data frame, which is our file names. So to make it clear to you, here we grab the first row from our data frame. And as you can see, here's our image file name and here's the label. Then we take this row and pass it to our getX. So, and as you can see, here's the return of our getX, which is the path of our image. Okay, and here's we make our getY. So our labels is going to be in the second column from our data frame. Then we create our data block and we create our data loaders and show 9 images from our data loaders. So let's go with the third method by using custom getItems function. So in this method we are going to create our own function that return both our x's and our y's. So here in the code, here we define a planet items function that take x as an argument and return tuples of 2 elements. The first element is going to be our image file names and the second element is going to be our labels. And here we define our data block and here we make our data loaders and show 9 images from our data loaders. Now we're ready to build our CNN learner. So to build the CNN learner, we need 3 different things. We need the data loaders, the architecture, and the evaluation metric. So for our architecture, we are going to use ResNet34. So here we import ResNet34 from torchvision.models. And for the evaluation metric, we are going to use accuracy multi, which is new metric. So why we didn't use accuracy metric? Because accuracy metric assumes that we have a single label classification problem and our task today is multi-label classification. So here we build our CNN learner, pass it our data loaders, our architecture, and our accuracy metric. And we told it that it's a pre-trained model. Here we define our custom loss function. So this function is similar to nn.cross entropy loss, but it flattens the input and target. It also includes additional arguments like axis, floatify, and thresh. So this function here decodes return true if the input is greater than the threshold, and this function activation here applies a sigmoid function to the input. So now we are going to find our optimal learning rate by using .lr find method. So this method is going to plot our loss function with our learning rate. Here we assume that the optimal learning rate at 10 to the power negative 2. So here we define our learning rate and train our model with 5 epochs with that learning rate. And here we save our model. Then we unfreeze our model by using unfreeze method and looking for another learning rate. So here we assume that the optimal learning rate at 10 to the power negative 5. So here we train our model with that learning rate with 5 epochs, and here we show our results. Okay, here's my notes for this part. And let's go with the second task. So for this task, we want our model to recognize unknown images. Just make it tells us that it doesn't know what something is. So for this task, we are going to use a bits dataset. So here we install fastai library, and here we import vision library, and here we grab our dataset. So the difference between utilizing multi-label versus single label is multi-label accepts your items to come in as a list. So if you want your single label classification task turn into multi-label classification, just wrap it into list. So now what we can do is to pass this list into our getY. So here we still have our regex labeler and everything is set up exactly like the first lesson, but now we pass this lambda function to our getY. And what this is going to do is anytime we grab our y's, it runs regex labeler first and then converted it into multi-label classification. So this lambda function is going to wrap our labels into list. So it make it turn from single label to multi-label classification task. So here we build our data loaders and show batch with 9 images as we did before. So here is the images. Then we train our model. So here we build our CNN learner, pass it our data loaders, our ResNet 34 architecture, and our accuracy multi-metric. And here we pass it our loss function with 0.5 as a threshold. And here we fine tune and train our model with 4 epochs. Then we save our model. And here we show the results of our model. Okay, so let's try some random images. You can search for any image you want and upload it to Colab, then do BIL image.create in order to create an image. So here we upload a donkey image and pass this image to our BIL image.create, then we show this image. And here we pass our image to our model to predict. So as you can see, here is the return is empty list. So this empty list tells us that our model doesn't know what this image is. And here we pass it a different image, and the return also is empty list. So that's it for today's video. Hope you enjoyed.